Hi there. Today we're going to talk about measuring segments. In the previous lesson, we talked about a lot of different things: points, lines, planes, segments, rays, lots of different things. Today we're specifically dealing with segments and talking about their measures. We have something that we call segment addition, and if it's just kind of, instead of dealing with just one segment, we're going to be combining segments together. So you can see right here I have this segment XY and this segment YZ. And my question to you is, how long would the segment XZ be? XZ goes from here all the way to here. Well, you can kind of look at it, and it's not rocket science. Oh, well, it's this 3 and this 6. Oh, I think it'd be 9 units long. Okay, let's make it a little bit trickier. How about in this picture, how long do you think YZ is? So that's this piece right here. Well, I can see here that the little piece is 3. I've made, now it has nothing to do with this picture. I changed the numbers entirely. Well, sort of. This is still 3. But the whole thing here from X to Z is 7 units. So then how long do you suppose just YZ needs to be? Well, hopefully you're thinking 4 would have to go there for that to add up to be 7. Now, one of the things that I want to talk about here is some notation. When we indicate the length of a segment, then we just label the 2 endpoints, and you do not put the segment above it. So it's going to be something like this. I'm talking about the length of XZ. I'm going to say XZ equals, and we decided that that one was going to be 9. I don't put the marking above it because I'm talking about the measurement of it. When you're talking about the length of something where it's actually a number, XZ, the length of it is a number, it's 9 units, do not put the segment across the top. If you're talking about the actual segment itself, then you put that segment across. So down here, when it says how long is YZ, I'd come back and say, oh, YZ is going to equal 4 units in this example. Don't put the segment above it. Now, that's actually that concept of segment addition. This is a postulate that we use a whole bunch in this course. It's called segment addition postulate, and it ultimately just says that if you add the 2 little segments, it's always going to equal the big segment. Add the 2 little parts equals the big part. So here is straight out of your textbook what they're talking about. If you have these 3 points and they're going to be collinear because it's going to create this segment where you have the 2 little parts and the big part. And the idea here is that if you take AB, which is this little part, and add the other little part, BC, add the 2 little parts, it's going to equal the big part, AC. So that right there, AB plus BC equals AC, that, when we see that, we have to recognize that as segment addition. All right, let's come down here and see. This is similar to the one we just, it's the same numbers even. I guess we've already done that. We already talked about how it equals 4. Now, that's pretty basic. You can just glance at those, and we start off with some easy ones for you. But ultimately here in geometry, what we're going to do is we're going to be using these geometry concepts, but pulling in the algebra that you learned in Algebra 1. So I'm going to use the segment addition postulate, but you can see here it's a little bit trickier. It's not numbers anymore. Now you've got algebraic expressions in here. So it's going to be a little bit trickier. We're going to have to do some solving. The idea is still the same, though. It says here that if EG is 59, notice they didn't put the segment because they're talking about the length of it. It's a number. EG is 59 units. Well, that's the big part. They're asking me what are the 2 little parts, EF and FG. All right, well, I can't tell with the way they're set up now, but what I'm going to do is set up an equation. I'm going to add the 2 little parts, make it equal the big part. So I'm going to take my little part, 8x minus 14, add to it my other little part, 4x plus 1, and say that it equals the big part. And remember over here they told me that the big segment EG is equal to 59. All right, so that's the segment addition postulate. That's the geometry in it. Now let's do the algebra in it. Over here on the left side, we're going to combine like terms. So I'm going to have a 12x. And then I have this negative 14 and this positive 1. That'd get me a negative 13 when I combine that. So I'm just cleaning up the left side, combining anything that I can. Now I'm down to this nice 2-step algebraic problem. Add the 13 to the other side. So 12x would be 72. Oh, that works out nice. If I divide by 12, do you remember that one? 72 divided by 12, that's 6. All right, so if x is 6, be careful because that's not really what they ask. The question was, what are EG and FG? So I have, I'm sorry, EF and FG. So I'm going to take this 6 that I got and I'm going to plug it in right here, and that way I can figure out what EF is. So 8 times 6, that's 48, and 48 minus 14 would be 34. So then over here, for my answer, what I would say is I'd say, using that, I can say EF is equal to 34. And then I'm going to do the same thing. I'm going to come here and grab the x that I have, the 6, and plug it in right here. 4 times 6 is 24, plus 1, that's 25. So FG is equal to 25. And you can do a quick check on that real easily. I can just line those up and say, yep, that adds up to 59, which is what I knew that was supposed to equal. All right, let's see if you could do one. Here's the you try this one on your own symbol. So this one's a little bit trickier. I've got the two little parts, but notice that the big part is not a number like it was on my previous example. It's another algebraic expression. Just means you got to work a little bit harder in your algebra. All right, I'm going to let you try this one on your own. Go ahead and set it up and go through and solve it. You're going to want to pause the video so that you get some time to do that. Come back when you're done. Okay, no cheating. You really have to pause the video and try it on your own. I set up, here it is, add the two little parts. It equals the big part. Pause the video, go solve it. All right, here it is, worked out. Go ahead and check your work on that. Make sure you got down to, I didn't really have a question on this one. I just threw the example up there. So what I've done is I went ahead and just solved for x, and then I went and found all the 3 different segments. Make sure you pay attention to the directions on your homework. Sometimes they just want x, sometimes they want all of it. You just have to answer whatever they're asking for. Now, as we talk about these segments, it says, and let's talk a little bit about that notation. It says if 2 numerical values are the same, then you say that those values are equal. 5 is equal to 5, or in this case when I'm doing segment xz is equal to 3, or whatever it might be. If you're talking about numbers, so that's the big thing, is if you're talking about numbers here, then you use an equal sign. But if you're not really talking about the number itself, and you want to talk about the actual segment, it says if 2 segments have the same length, then those segments are congruent. This is probably a new word for you. Congruent, you're not talking about a number anymore. You're talking about the actual segment. I think of it kind of like if I can pick one segment up and set it on top of the other one and they match up perfectly, then I'm talking about the segments. I don't really even care about what the length is. I just want to make sure the lengths are the same so that one will land on top of the other. If that's the case, then I use the term congruent instead of equal. So over here in my example, you can see segment AB here. That is 1 inch long. Oh, okay, so I'm talking about a number. CD is also 1 inch long. So I'm going to say that those are equal to one another because I'm talking about their measurements. Now, if I don't show that what their actual measurements are, and I come over here and say, see this segment AB and this segment CD, I can pick this one up and then lay it right on top of this one and they match up. This little hash mark here indicates that they are the same length. Okay, and we'll talk more about that in a bit. But that means they're the same length. So that means I can pick it up, land on top of that. Now I'm talking about the actual segment. So I keep the segment up here instead of removing it like I did over there. The segment's there, and I don't use an equal sign, I use a congruent sign. Now that's kind of tiny there, just so that you can see what it looks like. It's an equal sign with a wavy line above it. That's congruent. And we use that one when we're talking about the actual segment. Seems minor. It's just kind of one of those things that's going to come up. We call that the definition of congruent. This right here, this concept right here, that if they are equal, oops, I missed that. If they are equal to each other, then they are congruent to each other. All right, so if that's the case, that's considered the definition of congruent. All right, let's talk about something new. The midpoint, all right? This is probably a term that you're familiar with, but let's just talk about it in geometry and what it means to us. The midpoint of a segment is a point that divides the segment into two congruent segments. So you can have a point, a line, a ray, or another segment, anything that intersects your given segment at the midpoint. So in my picture here, this line L is coming through. B is the midpoint right here. So if that's the midpoint, L is coming through and hitting at the midpoint. Now, L is said to be bisecting. If it cuts through at the midpoint, then that means it bisects it. You can see here with my two little hash marks, that's indicating that this segment and this segment are congruent to one another. Now, we use 2 here. Sometimes we use 1 hash mark. Sometimes you'll see 3. The whole idea is that if they match, if they both have the same number of hash marks there, that means they're congruent to one another. So let's look at that with some algebra. I have an example here. It says Q is the midpoint. All right, got it. Q is my midpoint. So what that means to me then is if that's the midpoint, then this segment and this segment should be the same length. So now let's think about what we would do algebraically here. Last time when we did segment addition, I added the 2 little parts and made it equal the big part. But they don't tell me anywhere over here anything about what the big part is. I don't know what PR is. But I don't have to get that complex with it. If this is the midpoint, and I've already marked these 2 congruent, I'm not going to be adding them and setting them equal to something. They're congruent to one another. That means that their measures are equal. I'm just going to set them equal to each other. Like that. And that's my algebraic problem. All right, so let's do some algebra. Let's get the x's together on the same side. So that's x minus 7 equals 1. Add the 7. X is going to equal 8. All right. Now the question specifically asks, though, for each of the different segments. It says, what's PQ? Okay, so let's do that. PQ would equal... Oh, all I'm going to do is take my 8 and plug it in right here. That's 48 minus 7. That'd be 41. All right, now let's plug it into the other side. Put 8 in up here. That's 5 times 8. That's 40. Plus 1 is 41. All right, makes sense. Weren't they supposed to be equal? All right, so I'm glad that's a good check for it, I guess. Make sure they end up getting you the same thing if it's the midpoint. They also asked for PR, which is the entire segment, and they don't really give me any algebraic expression for that, but I'm just going to, in my head, do some segment addition. Add the 2 little parts, should equal the big part. The big part's going to be 82 there. All right, that's all we've got, doing some segment addition and some midpoint stuff. All right, hope this helps. Good.